Good afternoon and welcome to today's webinar on characterizing growth conditions of plants using multispectral sensors installed on a UAV. My name is Andrea Johnson and I'm from IdeaWorks, Mohawk's Hub of Applied Research and Innovation. On behalf of IdeaWorks, I'm thrilled to welcome Greg Matzke from Mohawk College's School of Engineering and Technology to deliver today's webinar. His research study explored how multispectral sensors, when installed on a UAV or a drone, could help determine the growth conditions of various types of vegetation, such as wine crops in the Niagara-on-the-Lake area. Greg will be making time for questions at the end of the webinar, so if you do have any, you're welcome to send them through the chat function or the Q&A function. Certainly, if they pop into your head early on, please feel free to send them along and we will answer them at the end of the session or as time allows. As a reminder, today's webinar is being recorded and will be available on YouTube after this session. And we also have closed captioning available. So thank you, Greg, for joining us and welcome. I'll hand the floor over to you.
Thank you. Good afternoon, everyone. As Andrea mentioned, my name is Greg Matzke, and I am a faculty member in the Chemical, Environmental, and Biotechnology department. I teach mostly chemical engineering courses, although I have a couple of the courses in the environmental stream. And one of the courses includes the GIS, Lab Computer Applications, and GIS. So the work that I'm going to present today is related mostly to this GIS, to the Environmental Technology Program. And I'm going to share the screen now. So I'm going to start from defining the main objectives of the research that we do in our department in area of environmental technology. Then I will briefly describe the approach that we take to few of the projects that we run in our department. Then I will try to show you a few additional small projects that were done by mostly by the students under my guidance. And then because we are talking about flying the drones, I will have to talk a little bit about the requirements, how we are allowed to fly the drones that are heavier than 250 grams, but not heavier than 25 kilograms. And then I will focus on the IdeaWorks Catalyst Fund ICF project, which was related to the flying the drones over the farmland, trying to use the multispectral camera attached to the drone. And at the end, I will talk about the conclusions and what would be the next in terms of the steps after those projects are done. So the main purpose of this research projects here is to get the exposure to the students so that they can learn the new technology. One of our mandates here is to include experiential learning in curriculum of whether it is environmental, chemical, or biotechnology programs. And beside the capstone courses that we have in our most often in the last semesters of the programs, we do have this opportunity to participate in the research projects where the students can get exposure to real industrial projects and learn this new knowledge in terms of the new technology. Additionally, when we have a chance to apply for those projects, we can get some funding, and this funding allows us to buy the equipment that obviously would be used in the projects, but after the projects are completed, we can use this equipment in the laboratory sessions when we teach our students the lab portion of the courses. And when we compare the MOHAC or the college education to university education, university is more about the theoretical knowledge, whereas the college level is more about the applied engineering, applied science. So the more equipment we can have, the better chances for the students to learn hands-on activities related to environmental, chemical, or biotech industry. I said at the beginning that when we run the project, we have a process kind of the approach here. We build we have like a process flow diagram for the steps in the project. So when you think about the flying the drones, it's not only learning how to use the joysticks and fly the drone and collect the images. So flying the drones is one of the activities, very important part of the overall project flow, but it is not the only one. So we normally start from defining the problem. Is there an issue with the system, with the process that we have to solve? Then we work on learning this new technology, learning how to fly the drones, how to meet the requirements. Then we fly the drones, collect the images, and then we will process those images using different software packages. And at the end, if we have too much noise in our output files, then we have to fine-tune our process, and then we are using analytic functions, the software that allows us to get better results, more accurate results from the process. And after this process, those projects are done, as the follow-up, we can communicate with the industrial partners, and also we can incorporate the knowledge that we gain throughout this duration of these projects into the curriculum, into the different courses in our program. So in this case, this will be environmental technology program at the MOHAC College. Before I try to discuss the multispectral sensors, I'd like to show a few smaller projects done by the students in our department. Within the last, I would say, 3 years. The last year was not the best one because of the pandemic situation, so we did not really have running projects. So we actually started with the Halton Conservation Area with trying to record the video of the controlled burns in Glen Orchy Conservation Area. This is actually behind the Oakville Hospital in Oakville, north from Highway 5. So this was one of the first sort of small projects done. And we were using Phantom 3 Pro drone. So we actually have Phantom 3 Pro and Inspire 1, the 2 drones in our department at this time. So not to run it for a long time, I'm going to speed up this process. So this might be useful for the crew that is responsible for controlling this burning process of the grasses. And actually the work was done by the professional team of the retired firefighters that they do conduct the controlled burns for different organizations. So everything was approved, everything was done under strict control. And this actually process allows for maybe running some kind of the feedback, getting the analysis of this process. Another project that we ran, it was a mapping project in Hamilton, Burlington area. I wonder how long it will take. Okay, here we go. So we tried to map the shoreline of Lake Ontario in the Catholic Cemetery at Plains Road. Okay, so basically, this is the polygon, the results of our flight over that shoreline. What I wanted to point out here is the couple of the ground control points. I hope that you will be able to see it. In order to sort of improve the accuracy of the location, the GPS that is installed on the drone is not so accurate. So probably you're talking about 2-3 meters accuracy. When we talk about the civil engineering surveying, we are talking about the centimeter accuracy. So in order to improve the accuracy for our mapping projects, we would install the ground control points. So 6 to 8 of these squares, you can probably see the black and white squares, few of them distributed here. And when we process the images, we would superimpose those ground control points that are measured using GPS unit that has higher accuracy than the drone GPS. So in this case, we had the GPS unit GNSS R1 that gives us the accuracy of 50 centimeters to 1 meter in reference to 2-3 meters GPS accuracy installed on the drone. So this can be done, the accuracy can be improved based on using the ground control points. And the next project is the project multispectral sensors used in the agriculture. And probably in 5 to 10 minutes, I will be talking about details in regards to this project. So as I said, that our approach to any of the project is following the engineering pathway of building the block diagram or process flow diagram, where we want to organize our activities in sequential order. And the first steps that we included was the preparation. In our process, this required obtaining the licensing to be able to fly the drones. Then detailed site assessment. So we had to pay attention if there are no obstacles in our area where we had to fly, maybe cell phone towers or hydro lines. All these details have to be troubleshooted before actual flying of the drone. We had to prepare documentation, including the weather forecast, permissions from the land owners. Also, we had to contact NAV Canada for getting the permissions. So if the flights were completed, were done in the area close to the airport, the tower was contacted, and we had to get the permission to fly. Talking about the actual drone flight, this flight can be done in different settings. One is called nadir, another one is oblique, and the third type is the terrestrial. So here we can see the nadir flight. So practically the drone is flying over the area with the camera pointing down. And with the predefined overlap, the front overlap and side overlap, the pictures are taken, and those images are downloaded to the computer after the flight. And we use the software, photogrammetric software, that would allow us to process those images to end up with a three-dimensional, maybe point cloud, or maybe with the raster file, which are actually GeoTIFF files. The oblique flight is flight around the point of interest. So we can, or you can set up the drone flight path so it flies in the circle around the object with the adjustment of the camera that would focus on this point of interest. And again, here we can set up the flight. So there is set overlap when the drone takes the picture. And then terrestrial flight is a more vertical flight when you can get the mapping or generate the point cloud when you have steep slopes, because the nadir flight is not so good when you have vertical slopes. It will not capture the details of the terrain. Then when we fly, we have to discuss whether ground control points are required if we need the higher level of accuracy of the final product that we want to get at the end of the project. The next step after the flight is done, the images are captured. Then we push these images through the number of processing softwares. And the first one would be photogrammetric software that allows you to stitch those images. So when you have the overlapping images, overlapping pictures, the front overlapping or front overlap and side overlap, the points on the ground are captured. If you have side and front overlap, then the point on the ground is captured by the 4 photographs. So now when you process this, let's say 4 images, overlapped images, then the software would produce the photogrammetric output. This is called the stitching process, where the point becomes 3-dimensional point. So after this processing, these 3D points can be rotated, zoomed in or zoomed out. And this is how you create the point cloud and 3-dimensional object running the processing of these images. So potential products coming out from the processing of the drone images would be the maps, the digital maps. We call it orthophoto maps, 3-dimensional models, digital terrain models, digital surface models, contour maps, reflectance maps, and I will talk about the reflectance map in terms of this multispectral cameras in a few minutes. Reflectance map, it goes parallel with the index map. Also, we can use the processed images as we are getting point cloud and 3D models. We can calculate the volume and or areas of the objects that can be used in more engineering work later on. And if these processed images are not good enough, if they contain a lot of noise, we have to run additional processing of these images. In this case, this would be GIS, Geographical Information System software. In our case, this would be the ArcGIS Pro that would allow you to remove this noise from the final product. And here we can generate the KML files, the HTML files that we can share with the public. Everyone can access. You don't really need to have ArcGIS software to view those files. You can get the 3D models as one of the products coming out from analytic part of the images. So let's spend a few minutes now and talk about the requirements for flying the drone, because this process is not difficult to just connect the remote controller to iPhone or maybe to tablet. Turn on the drone, turn on the receiver, the remote controller, and using the joysticks like playing the computer game, we can easily fly. But if we have a drone that is heavier than 250 grams, then in addition, if we want to fly the drones for the purpose of the business purposes or for the research, then we have to have permissions from Transport Canada. And prior June of 2019, for any business-related or research-related flights, we had to apply for SFOCs, Special Flight Operating Certificates. And this was happening the first few times we had the drone, we used the drone for the project. we had to apply for each flight. We had to send the request with the documentation to Transport Canada for the approval. After 3-4 flights, we were granted the 1-year permission to fly in Ontario in controlled airspace. This regulation changed in 2019, and from that time, in order for us or for anyone to fly the drones, you have to have a license. And there are 2 different levels of licensing. The basic license, that is can be we can get this license by writing the written test, online test. This is the basic exam. What it allows us is to fly in the uncontrolled airspace where there is no air traffic control tower. Also, we have to make sure that we are not flying close to the public, close to the people. If we want to fly in area in the controlled airspace, where we do have air traffic control processes happening, and closer or closer to people than 30 meters, then we have to have the advanced license. Again, this is mandated by the Transport Canada. And in this case, we have to pass the theoretical online exam as well as the flight review, which is the practical exam. And this is valid for 2 years. If we have to fly over the crowd of people, or if we have drone that is heavier than 25 kilograms, then we have to notify it and we have to apply for that SFOC, Special Flight Operating Certificates from Transport Canada. We have to get the approval for this process. This couple of the slides were directly copied and pasted from Transport Canada website. Here we can see that all these flights that are being done with the drones are called the within the visual line of sight, VLOS. You cannot fly that we cannot see the drone. So everything that is happening in terms of the drone projects, we have to be able to see the drones flying. And the altitude is not higher than 400 feet above the ground. And again, if we want to fly within the 30 meters distance from people, we have to have the advanced license. Also, the advanced license requires in order to fly within the controlled airspace, we have to have this advanced license. And there are also limitations set for the distance from the heliports and the distance from the airports. We also have to remember that flights done using the drones after 2019, the drones have to be certified. So we have to register drone like registering the cars trying to get the plate. So the same situation is applied to flying the drones. So now it's time to look at the project, the multispectral sensors that we installed. In this project, we use the DJI Inspire 1 Pro drone with attached multispectral camera, Red Edge MicaSense. In this picture or the slide, we can see that the flow of the project. So we did some preparatory work. We were able, getting the funding from the IdeaWorks, we were able to buy the camera, the multispectral camera. Then we had to get the approvals as FOCs for the flights, because again, we started this project before 2019. Then we completed a number of flights over 2018 and 2019 at the winery in Niagara-on-the-Lake area. And we collected hundreds of images. Because now we have 5 different sensors or 5 different lenses, 5 different cameras, each lens was capturing one image, and these images were done at the different wavelengths of the electromagnetic radiation. So after the images were collected, we processed those images using photogrammetric software, Pix4D. And after this processing was done locally, we uploaded the raster files into the online software. It was MikaSense as Atlas software. And by uploading the processed images, the online package allowed us to view number of different indices indicating about the chlorophyll concentration, amount of water, and other environmental factors. These processed images uploaded to the Atlas software were not good enough because of the characteristics of the grape plants. They are not growing across the field evenly. You have rows of these traps, and the traps we have grass and we have soil. So this created quite a bit of the noise, and this processing done by Atlas was not good enough for us, and therefore we had to move into the ArcGIS software, ArcGIS Pro, to instead of the analog steps and function in order to extract only the grape plants for our analysis, trying to get information about the chlorophyll concentration, about the growth conditions of these plants. So a little bit of the theory. I'm not sure whether everyone is familiar with the multispectral cameras and the reflectance. So when we talk about measuring the reflectance, in this case, we can talk about the active sensors and the passive sensors. So the passive sensors, and the red edge is an example of the passive sensors, it would capture the natural radiation from the sun. If we talk about the active sensors, there is the source of the emission of the radiation, and then the detector that would pick up this signal. So in this case, this is the passive approach here. And we use the MikaSense Red Edge camera that had, as I said before, 5 sensors. And those sensors were blue, green, red. So that's our visible spectrum. And red edge and near infrared. So that's the wavelength on the x-axis. And on the y-axis, we have % of transmissivity. So 2 things that we have to pay attention here is the wavelength. So let's say blue would be around 475 nanometers, the green 550. So we can see blue, green, and red, but we don't see red edge and near infrared because we are sort of going above the 720 nanometers. So the wavelength is one important factor here. And the second one is how wide this wavelength is. What is the bandwidth? So we see that we go between 650 to 680. Here we go 800 to 850 nanometers. So this is important because these different sensors in remote sensing would give you the different sort of data that can be used for different projects. So that's one part. 3 blue, green, and red visible. Red edge, near infrared, we don't see it, but the sensor can see it, and that's what we can use it later on in our analysis of captured data. So on the right-hand side, we can see the response of the sensor when we have the blue, green, and red, and the red broken line is the vegetation that is sort of stressed. There is something happening to the growth of the plant, and the green one is the normal, is the healthy plant. So why do we see green leaves? Because the reflectance is higher than the blue and red. But what is happening with the red edge and near and infrared? We don't see, again, we don't see these 2 wavelengths. But if we have high reflectance of red edge and high reflectance of near infrared, it will give us some information about the health conditions of the plant. So this schematic here would probably be easy to understand. So when we have a healthy plant, then near infrared reflectance is high. Okay, so this is near infrared. The level is going to the top in reference, excuse me, to blue, green, and red. When we have some problematic symptoms, the near infrared reflectance would be decreasing. And if we have really bad situation, if we have a dead vegetation, then response would be even lower for the near infrared. So in remote sensing, we can use different indices that would guide us and give us some information about, are we facing a problem? Do we have local hotspots on the maps or not? So NDVI is one of the first indices that would give us some indication about health conditions. So the higher the NDVI value, the better the condition, the growth condition, the health of the plant. So here we can see an example of 60% near infrared and 5% red reflectance. So when we use the mathematics here, our NDVI index would be 0.85. Healthy plant, high vegetation index. When we have some issues with the plant, then let's say our near infrared response would be 40% and red 25. So by putting these numbers, NDVI index would be 0.23. It means that if we have a low value of that index, that we have to physically go into the field and we have to inspect what is happening. Is it the infection, the insect infection, fungal infection, not enough water, not enough fertilizer? So as I said at the beginning, we did complete a number of flights over 2 years in one of the wineries in Niagara-on-the-Lake area. And we actually ended up with 4 different polygons. So this is the area, this is one of the polygons. Then we had another flight here, another flight here, and another flights here over 2 years. And we actually going through this requirements of the SFOCs, of the licensing, of the insurance, we were ready to fly. In order to get connectivity of the remote controller with your drone, and you have to establish the flight pattern and the locations where the pictures would be taken. That was a nadir flight. So this image is taken directly from the iPad when the app or the program for the flight was installed. Then the images collected were processed by the photogrammetric software Pix4D. The stitching process was done. And again, if we have the side overlap and front overlap, the same point on the ground is captured on 4 photographs. And then when we go and try to stitch this 4 photographs, the pixel that is on the 4 photographs, we will be able to manipulate this picture. We get a 3-dimensional reflection of picture of this pixel and the object on the ground. And here on the right-hand side, this is a sample output from the Atlas software showing one of the vegetation indices. This is the online application of the MyCaSense or MyCaSense product. So here the output on this slide shows the actually Atlas MyCaSense software. So the stitched images as the TIFF file were uploaded to online program software. And here we can see that we can select the different options. We can see the chlorophyll map, we can see NDVI, digital surface model, RGB, red, green, blue composite. So different options that we can turn on or turn off to see the response. Again, working with the 5 different bandwidths of the electromagnetic radiations: visible, 3 visible, and 2 invisible. As I said, the grapes are not very good vegetation for a simple analysis using the stitched images, pushing them into the Atlas software because of the soil or because of the grass that would interfere with the actual analysis of the vegetation here. Okay, so when you are not going to select only the gray plants, the analytics software will give you the NDVI or NDRA or other indices that are representing the average across your field. But you don't want to have the grass because the grass would be a big contributor into your high value of the vegetation index. So therefore, we use the ArcGIS Pro software that allowed us to mask the area of our interest. So we masked only the gray plants, and then we applied analytics using ArcGIS Pro into only selected rows of the polygons that we had, and those polygons were our gray plants across the field. So the ArcGIS Pro allows you to create this areas. Okay, so when we see here, we have a little bit more red. Those strips are extracted polygons, and they represent the gray plants. The grass and soil were rejected in our analysis. So we can sort of look at the areas. You see that a little bit more bluish color is here. So we grab two polygons, A and C, and then we grab polygon B, which is a little bit more reddish. So you want to see a little bit of the statistics response, what we have in terms of whether it is NDVI or another index. So not much difference is showing here, the MSAVI index that we used here. But as you can see, polygon A and polygon C look a little bit similar here with the mean of 0.61 of that index and 0.55. But the shift of the frequency here is showing in polygon B. Okay, so by actually selecting the areas, we can first identify if we have any potential problems happening to our vegetation. And we normally might not be able to see it using the regular cameras, red, green, and blue, because of the reflectance value when we add this red edge near infrared, where when the plant is healthy, the reflectance is high. If the plant is not healthy, the reflectance of this non-visible part of the spectrum is low. And by this analytics, we can go and early enough state that something is happening with that area of the field. So when we talk about the software, there's so many different software packages we used in our projects. So just to try to organize what we had the DJI Go software application. So that's app on the mobile device, so on the phone or on the tablet that we can connect into our remote controller for the drone. Then we had the Atlas Flight. So this is another app installed on the phone or on the tablet that allowed us to communicate with the camera, with the red edge sensors. These cameras have their own GPS receiver. The drone has its own GPS receiver. But in order to be able to capture georeference images, and in order to be able to talk to the settings on the cameras, we had to use the Atlas Flight and Wi-Fi connectivity. Using the tablet, we talked directly to the camera, not to the drone. Then we had the Pix4D mapper. So that's the powerful software for running this stitching processes, photogrammetric software, and exporting the images into the Atlas. And Atlas, MyCaSense Atlas, was the software that was online package that we could upload the stitched images from Pix4D, and Atlas allowed us to create those NDVI, OSAVI different indices, vegetation indices. And at the end, we use the ArcGIS Pro software that allowed us to fine-tune our results. So in summary, we don't have much time left. So I'd like to say that the pre-flight activity and data post-processing was very time-consuming, very demanding, accurate preparations. It was because we were doing it first time. To connect everything together was quite challenging. It was steep learning curve for us. The procedures had to include the documentation, preparation, site assessment, troubleshooting processes. And obviously, for now, we have to have the license, the valid license. And most of the areas in Hamilton, Toronto, that's a classified airspace. So you have to have, or we have to have the advanced license. The post-processing stage was considered by us by using different software packages. In this case, we used the Pix4D mapper. Then we used the ArcGIS Pro for analytics and for fine-tuning, cleaning the undesired grass patches between the grape plants. Different indices can be used. We use the NDVI and MSAVI index. The results can be analyzed in terms of the, so that's for the future. It can be analyzed in terms of the effective usage of land and the amount of fertilizer used during the grape season, as well as early detection of the potential stress in the plants. So that's the potential applications, because if you can sort of identify the areas of problematic areas, you can sort of put a little bit more fertilizer, you can maybe put a little bit more water into this area. This way you can optimize your farming process. Okay, and as the follow-up, we just demonstrated the technology here. By the ICF funding, we were able to buy the camera. The camera was around $7,000 or $8,000 that we had to buy it. We did have the drone, so we added camera to the drone. The options for the future is to, again, apply this technology into the real scenarios if there are potentials with some problematic spots in the farms. That's good way to maybe try to potentially solve the problems. The newer cameras have 10 sensors, so another probably $10,000 would help to generate additional indices and compare these indices to the sensors that are on the satellites. Okay, one of the potential follow-ups could be work with the satellite images, because we do have free data that we can download the scenes from satellites, from Sentinel or Landsats, and we can try to compare the images from the satellites to the images collected through the drones. So obviously the resolutions would be the key point, because flying over the farm with the drone under 60, 70 meters above the ground gave us the pixel resolution around 2.5 centimeters. But when you are flying, when you are trying to use the satellite scenes, then this resolution probably would be around 1.5 meters multispectral from the multispectral sensors. And also as the follow-up, I started incorporating our findings into the curriculum of our environmental technology program. And also we did write a couple of the lab manuals, lab protocols for using the GIS software, using the data capture from the drones. And at the end, I'd like to acknowledge the winery, Herner's Winery, for allowing us, giving us the access to the fields, Royal Botanical Garden, Halton Conservation, Hamilton Catholic Cemetery, the Ideal Works department, also the CSEP program, because thanks to the CSEP funding, we were able to have a couple of the students that were critical in executing a number of these projects here, and the Chemical, Environmental, and Biotechnology department. So thank you. I think that's the last slide. I'm going to stop sharing screen. And if there are any questions, please go ahead. It's 2:45, so we should have some time for the Q&A. Yes, go ahead. I don't know if you probably have to unmute microphone. Andrea, can you help here with?
Masood, you should be able to unmute yourself. Thank you for raising your hand. I'm just going to ask you to unmute, but you're allowed to talk.
Masood, can you hear us?
Masood, you can talk. In the meantime, if there's any other questions, please feel free to share them through the Q&A button or the chat. Give everyone a few minutes to think if there's anything. Masood, while you're just looking to see about activating your audio, Greg, I did have a question.
Sure.
Realistic is this technology to adopt for the average farmer or the average winery operator, considering some of the technical requirements and the financial requirements?
I think this is doable technology. About the cost of it, I don't know. I think that if you have farmers that have quite large areas to manage, this would be very useful and maybe worth to invest. So either you can send the farmer to be trained, and maybe the cost of the drone with the cameras would be probably around, I would say, $15,000. The training would be maybe another $1,000 to $1,500. The access to the software, there are two different venues in industry. The best is if you have your own software on your computer, because you can manage, you can process the images, and you can produce your maps, and you can fine tune, you can remove the noise. But also you have a number of platforms. So for example, Drone Deploy would be one of them, that you have your images captured by the drone, and you upload those images to the server, and they will take care of the processing. But I don't know to what degree you would be able to fine tune. So the gray plans are a little bit tricky, as I said, because you do require to do the post-processing cleaning of the noise. Again, maybe it was not visible clearly, but on your maps, let me see, maybe I can share the screen here, is that share the screen. Okay, so this is the MicaSense, the atlas that, okay, we can check different indices here. And you drop down the arrow here, you have some kind of the definition of the index. I'm trying to find the desktop, one moment here. Okay, now I can share the screen. Okay, so this is the ArcGIS Pro software that at the college we do have the site license, so we can use it. But if you are actually thinking about buying the software, it probably would be expensive. But definitely there are the companies that they would do processing for you. That's one option. And another option, this would be worth to try out as another maybe smaller research that would probably not require to buy the equipment, but to compare the satellite images. As I said, you do have access to free material, free scenes. You don't have to pay for medium resolution TIFF file. So TIFF file is your map, where you get the pixel resolutions probably around 30 meters. But when you want to have high resolution images, the pixel resolution would be for panchromatic would be probably around 50 centimeters, but for multispectral would be 1.2 to 1.5 meters. So if you have farms of, let's say, corn or beans, you have like an even distribution of the plants across the field. You don't have much bare soil unless after planting. But when you are talking about a full season, you have the even coverage with the green color. So then you probably not have to use that fine tuning that ArcGIS Pro. The Mica Sense would be good enough. And again, it would be worthwhile to try out to buy higher resolution satellite images from the satellite programs providers, where you have this resolution 1.5 meters, but applying not to the grape fields, applying to the more evenly distributed plants. So this is something that I could think about maybe working in the future if this would be good enough, because if satellite images, you can buy your scenes for a couple $100 per, I don't know, maybe for 10 acres. I'm just guessing the cost right now. You could compare your satellite output to the satellite output to your drone output after analysis, and sort of do some kind of cost comparison, which would be, you know, is it good enough? Is it not too expensive, or is maybe too expensive?
Great, thank you.
Questions here.
So yes, we have a few. I'm just going to, so we have a comment, and then we have 3 questions. So we'll do Masood's comment, then we'll do Dave, back to Masood, and then Lindsay, just to make sure everyone knows the answer. So Masood just notes that this is a great idea, and it would be great to have more details available, just because the terminologies are new to him. So Greg, I'll make sure that we have your email available for future follow-ups. I'm just going to quickly go over to Dave's question in the chat function. What comments do you have on the validity of and/or the normalization process required to evaluate NDVI that was taken on different days, sun position, cloud cover, etc.?
Okay, that's a good question. Actually, I forgot to mention about that. We are going into the details here. So when you collect the images from the field, the software that you are using allows you to take the reference image of the I forgot how you call it. This is like a reflectance panel. So it is maybe 10 by 18 inches plate. You open it and you have the reference plate with it's like a whitish color, and you take, depending on the software, the older software packages, you take the image, you take the picture of that panel. It's like a piece of paper, and then you add this picture to your software, and when the processing is done, when the stitching process is done, the software will get your normalization in reference to the cloud cover and amount of sunshine that you have. Your denominator here would be the panel, the picture that you take from that panel that is provided with the camera. And with the newer updates or the softwares, you can take the picture of that reflectance panel, the template before the flight and after the flight. And software somehow would process it. It would normalize your reflectance. Obviously, even when you fly at 10 o'clock in the morning, and then when you fly at 11:30, and then when you fly at 4 p.m., there will be the difference in the reflectance. So yes, first you have to pay attention, try to fly around the same time in the same weather conditions. But if this becomes, we cannot do it, then you still have to use this reflectance panel when you take the picture before or after, or before and after, and you upload this picture with your images, and the processing is done by the software. I don't know if it's clear or not. It's a bit complicated.
Dave, comment if you wanted to know a bit more about that. I'm just going to keep going on the next question, recognizing our time constraints. So Masood wants to know if there's any opportunity to be part of this project. He and his friend are into helicopter piloting, and they're thinking about cross-busing in the GTA areas. So I'll start by saying that the college is always looking for applied research partners for a wide range of opportunities. And then I'll hand it over to you, Greg, to maybe share a bit about your plans and opportunities.
Can you repeat, Andrea, because I lost you. I
Sure.
lost the internet for a moment.
Oh, of course. Is there any opportunity to be part of this project? My friend and I, who are helicopter pilots, are thinking about crop dusting in the GTA areas.
Actually, the project is done for now, and because of the COVID, everything is sort of frozen right now. We are working. We teach from practically from home, unless there's few programs where the labs have to be face-to-face, like nursing or aviation. I do not have any plans for now. I'm set for the summer to teach and for the fall to teach, but again, I'm open for any potential work. And really, I'd like to find the farm that someone is complaining about some issues. And then if we can fly the drone, collect the images, process the images, and then really prove that if the farmer is suspecting this area in, let's say, northern eastern part of the farm, we fly, collect the images, and then physically go and check it. In fact, if there is the problematic spot. What we found from this winery, if you remember this polygons A, B, and C, after I talked to the grower, it turned out that there were two different varieties of the grapes. So this was like Cabernet Franc, another one was another variety of the grapes. So we were able somehow to detect the difference in the, even though like visible, you don't see it. When you are in the field, you don't see it because green is green. But with the near infrared and red edge reflection and reflectance, you can see this difference. So to answer the question, I don't know. I think that this is the potential, and having these cameras, this is not, I think, something very difficult, and it can be done. And hopefully the COVID could be sort of diminished, and then we can get back and resume our regular in the building activities.
Great, thank you for that answer. Lindsay, I think we have time for one last question from Lindsay. She just wanted you to remind us of how long it took from planning to using the data.
From planning to using the planning, the project, troubleshooting, or planning the flight and getting the data, because the first is very long time and a lot of problems, even with the connectivity of the iPhone to the camera. As I said, there is a problem. There is an issue, like two different GPSs, one on drone. So when you fly the drone, the GPS on the drone is used to control the flight path. But then your camera has its own GPS. So there's another GPS on the drone, and you have to talk to this GPS. You have to talk to the camera because you have to set up how often do you want to take the pictures, and how often you want to take the picture would depend on how high you are flying and what speed of this. So there are many factors. So I would say the first time you do it is time consuming. The second time you do it is medium time, and the third time, fourth time you do it, it becomes a routine when you troubleshoot the process. We are not at the stage that we can sort of fly on the regular basis, but again, with the practice, it becomes more obvious, easier. But I would say couple of, just the flying is couple of the weeks, you set it up and then you can fly. But if it is a new project, I would say couple of the months, if not longer.
Wonderful. All right. Well, it's 3 p.m. So that comes to the end of our webinar. Thank you so much, Greg, for your time. Thank you for attending.
Thank you.
Joining us. We'll be posting this video to YouTube in a few weeks and sharing it on our social media pages. Certainly, if you have any questions, please feel free to email ideaworks@mohawkcollege.ca, and I'll be happy to get you in touch with Greg. Thank you.
Thank you, everyone, as well, for the attending. And I think it is very exciting technology. And if we can sort of get the students participating in these activities, this would put our students on the higher level, and definitely it would be much easier for them to end up with the full-time job placement after they graduate from school. So thank you.
Thank you, everyone.